Hi, now we are going to discuss how to delete a node from the linked list. Deletion is nothing but removing the node from the linked list. The deletion of node or removing the node from the linked list may be either it may be starting or it may be end at any position. So now let us know how to delete the element at the begin from the linked list. Now you can see the function name is remove first node. So first of all, you need to identify if you want to delete any node from the beginning, let us know whether self.head is available or not. When the self.head is available, then we can delete the node. So, sir, as a programmer, as a developer, we think a negative side also. If the self.head is none, can we delete? No. So that return. So if the self.head is none, we can't delete any element from the starting because there is no linked list. Else, if the self.head is available, then we can take a temporary variable that starting node will going to store in a temp. Now let's see there is some nodes 9, 12, 19, 23. Now the 9 will be going to store in a pointer head and the last node 23 will be null. Now we are going to delete the starting node. So if you want to delete the starting node directly, if you want to delete anything, we need to make that node next null, right? So this node next null, then automatically the link will be gone. Okay, this node A next null means there is no element afterwards, means this link gets disconnected. But the first node is always pointed by the head, right? The first node is always pointed by the head. If you delete this first node, the head pointer also gone. We can't identify the remaining part of the list, linked list. So that take a temporary variable first. Okay, take a temporary variable first and store that head pointer into temp. Then self dot head is equal to temp next. It means we are making the temp next. What is temp here? No, now we are assigning a temp right here. So we are assigning the first node as a temp. Now the temp next is what? This 12th node, node B. Temp next is node B, right? So temp next, we are making head as a temp next. So we are making the temp next as a head. Temp next is nothing but node B. So we are making the second node as a head. Then later we can delete the first node. So if we want to delete the first node directly, we lost the head pointer. So then take a temporary variable and temp next. We are making the second node as a head. Then you can remove this first node. How do you delete? Temp next is equivalent to null. None means null. So temp next is equivalent to none. Anyway, temp head is here in the second node. Now temp next is null. This link gets disconnected. Simple. So now after deleting, the remaining nodes are 12, 13, 12, 19 and 23. Now it's simple, right? Now this is the way we are going to delete the first node from the linked list. Okay, while deleting the last node, as like insertion, you need to reach the last node because we need to add a node at the end. We need to delete the node end. So we node next must be null. Then only we can delete that node. Okay. So now we are going to take an extra variable previous, pre and temp. So in a temp, I will tell you what is the need of taking two variables. For example, 3, 12, 15 is the elements. Now 3 next is the address of the 12. 12 next, here it will store the address of 15 and 15 next is null, obviously. Now we need to delete this node. How do you delete? Temp next, take a temporary variable and temp next, we need to search for the null. So if you want to disconnect this node, you need to stop here only, right? Okay, this node next be null. Okay, you need not to traverse up to here. Okay, no need to traverse up to last node. Just move just before this last node. And you should not reach to the last node, reach up to previous node. So previous node which stores the self dot head, starting node. Okay, initially, so previous and temp is actually self dot head dot next. So what is self dot head ma? Head is the starting node, head next is the second node. Now self dot temp is actually the next node. Okay, getting my point? So first, previous is the first node, temp is the next node of the head. Self dot head dot next means the head next. What is head next ma? 12th node. Okay, head next is 12th. So now the temp is here. Now temp is here. Now the previous is here. Okay. Now temp is here. Now the previous is here. Now while temp next is not none. Anyway, temp next is not none, right? Then temp will be incremented by 1. So similarly, previous is equivalent to previous next. So 2 pointers will be moving. Now the temp is here. Finally, temp will be moving to the last node. Okay, now you can observe carefully. Now the temp will be incremented and now the temp will be moving to the next node, that is 15. Now where is the temp? Now temp is here. Now we can't delete temp directly because if you delete the temp, we can't identify the previous one. Now similarly, previous is equivalent to previous next. Similarly, previous is equivalent to previous next. Actually, the previous is here, right? Now the previous is here. Okay. And later make, now previous is here, temp is here, previous next. Now here there are two partitions, right? Previous next is the address of 15, right? Make it as a previous next is equivalent to null, then automatically this link gets gone. Okay, previous next. Now temp is here, temp is pointing to the last node, previous is the node which is pointing to the previous node of the temp. Now previous is equivalent to previous next is equivalent to none. So now automatically this link gets disconnected. I hope you understand. Disconnect the link. Now you understand? I hope you understand how to traverse from the starting node to the previous node of the last node. Now after deletion, these are the nodes 3 and 12 are remaining. Now cross verify. So I want to delete this node 6. Okay. So you have to reach the memory location as like insertion. You need to reach up to the previous node. Then you can make it this node next null. Otherwise, directly you can connect this node next to the next node of the particular. Now coming to the programming wise, if self dot head is equal to none, we can't delete anyway, it return. Take a temporary variable, that is the first node will going to store in a temp, and position is equal to 0. Let us assume position is equal to 0 means 0th memory location element is 3. Make it as a position 3. Now we need to mention the index where you want to delete. Okay, now index is the parameter that we need to pass. If the position is equivalent to index, what is the position initially? 0. Okay, if the position is equivalent to 0, if you want to delete that node, call remove first node. Okay, we are not writing the logic here, simply we are calling the function which is already written, remove first node, because the position is 0. 0th location value means what now? First node. So that we are simply calling the first node function. Otherwise you can write the logic here, okay, instead of that, because I have written the code anyway, so that I am calling the first node function. Else if the index position is not 0, what we can do? So we are searching temp next not none and position plus 1 is equivalent not equivalent to index. Okay, listen carefully. Temp is actually self dot head is right. If the self dot it is not equivalent to none, and there are some elements, and position plus 1 means 1th location, means next element. The next element is not equivalent to index. Now the position will be incremented by 1. Okay. Next temp also will be incremented by 1 if it is not exactly a index. Okay. Just simply we are incrementing the pointer 1 by 1. Okay. When if it is not a position, when it is not a temp is equivalent to not none. Then if temp is equivalent to none, temp will be incremented by temp next. Else index is not found simply. Okay. So simply we are making this the position, and this loop gets repeated. When the position is equivalent to index, we are going to call the first node. Now likewise, this is the how the remove at particular position will be. We are going to identify the deletion node. Okay. At position 2, the index is 1, the position is 2. Index is 1, the position is 2. Okay. So now we are going to delete. Just simply we are making this node next is equivalent to temp next. Okay. With this, because this node is disconnected, we need to connect 3 to 12, 3 with 12. So this temp next is equivalent to that next of that particular node. So it's simple, and try to trace it. You can easily understand how to remove the node from particular position.